Frequency and relative frequency distribution tables, along with frequency bar plots and histograms, are considered the basic visual summaries of any data, as they can be constructed for any type of data and essentially provide all the information one may need to know about the given data. However, statisticians continue to invent ways to display data. Next, we will discuss some other, less common ways used to visually summarize the data. One method developed in the 1960s by the late Professor John Tukey of Princeton University is called a stem and leaf diagram, or stem plot. Let's consider again the ages of the presidents at the time of their inauguration. We're going to construct the stem and leaf diagram by first constructing the stem, the list of the first digits of all possible ages. And then we're going to draw the leaves, one for each president's age. First, we have Washington at the age 57. 57's first digit is 5, so we're going to draw the value 7 in the row corresponding to the value 5 in the stem. Next we have 61, so the first digit of 61 is 6, so we're going to draw the value 1 in the row corresponding to the value 6 in the stem. So altogether it reads as 61. Jefferson 57, the first digit is 5 and the second digit is 7, so we're going to draw the value 7 in the row corresponding to the value 5 in the stem, and so on. Once the diagram is complete, we can sort the values in each branch in increasing order. When the branches are too long, we can split the branches by assigning a portion of the branch, in this case the values from 0 to 4 to 1/2 and the values from 5 to 9 to the other half. In summary, to construct a stem and leaf diagram, first think of each observation as a stem, consisting of all but the rightmost digit, and a leaf, the rightmost digit. Then write the stems from the smallest to largest in the vertical column to the left of a vertical rule. Write each leaf to the right of the vertical rule in the row that contains the appropriate stem. The next two steps are optional. You can arrange the leaves in each row in ascending order, or you can split the stems. This ingenious diagram is often easier to construct than either a frequency distribution or a histogram, and generally displays at least the same amount of information. Here are a few tips to consider before making a stem plot. Stem plots do not work well for large datasets, where each stem must hold a large number of leaves. There is no magic number of stems to use, but 5 is a good minimum. Too few or too many stems will make it difficult to see the distribution's shape. If you split stems, be sure that each stem is assigned an equal number of possible leaf digits. For 2 stems, each must have 5 possible leaves, or for 5 stems, each must have 2 possible leaves. You can get more flexibility by rounding the data so that the final digit after rounding is suitable as a leaf. Do this when the data have too many digits. For example, in reporting teachers' salaries, using all 5 digits in a number 42,549 would be unreasonable. It would be better to round to the nearest 1,000, 43, and use 4 as a stem and 3 as a leaf. Alternatively, we can use another type of graphical display for quantitative data called the dot plot. To construct a dot plot, we're going to draw a horizontal axis that displays the possible values of the quantitative data. We're going to record each observation by placing a dot over the appropriate value on the horizontal axis. For example, Washington 57, we're going to draw the dot above the value 57 on the x-axis. Adams 61, we're going to draw a dot above the value 61. Jefferson 57, we're going to draw another dot stacked on top of the previously drawn Washington's dot at 57, and so on. Dot plots are particularly useful for showing the relative positions of the data in a dataset or for comparing two or more datasets. In summary, to construct a dot plot, we first draw a horizontal axis that displays the possible values of the quantitative data. Then we record each observation by placing a dot over the appropriate value on the horizontal axis. And finally, we label the horizontal axis with the name of the variable. Why bother with learning different ways to summarize data? The advantage of dot plots and stem and leaf plots is that both of them can be constructed as the data being collected. That is, we do not need to have access to the entire dataset to start visualizing it. Also, they make it easy to compare two populations side by side. We can use a back-to-back stem and leaf plot by drawing a stem and adding leaves for one population on one side and for the other population on the other side. Or we can also use the dot plot in the same way by drawing the dots for one population above the x-axis and for the other population below the x-axis. As an alternative to drawing the vertical bars in histograms, we can mark the frequencies with points and then connect the points with lines. Such a summary is called a frequency polygon, and it can be used to save ink in your printer. Another common way to organize the data is to use a cumulative frequency. A cumulative frequency of a class is obtained by summing the frequencies of all classes representing values less than the upper limit of the given class. The last entry in the cumulative frequency column must be equal to the total number of observations. A cumulative frequency polygon that is constructed using the midpoints on the horizontal axis and the cumulative frequencies on the vertical axis is called ogive. We can easily do the same with relative cumulative frequencies. We discussed a variety of alternatives to the two basic visual summaries, frequency tables and histograms.